Hello and welcome to video number 13. My name is At-Tayyib Abu Yaman. We will be discussing integration of the function sin x cosine x. To that end, we will discuss 4 different results of the same integration. To start with, this is our problem that we want to solve: integration of the function sin x cosine x dx. We will use integration by substitution. First, we'll substitute for sin x. Once we get the result, we will switch and substitute for cosine x to get a different result. To start with, let u equal to sin x. If we differentiate both sides, then we will get du equal to cosine x dx. If we divide each side by cosine x, we will be solving for dx. So dx will be equal to du divided by cosine x. Now we're ready to plug in. So the substitution will be, instead of sin x, we will use u because u is equal to sin x. Cosine x, we'll keep it untouched. dx will replace its value, which is du over cosine x, which is right here. Now we realize that we have a common term in the numerator and denominator. Let's eliminate that common term, and that will help us reduce the problem into one that is simple to integrate, which is just integration of u du. The result of the integration is u squared divided by 2 plus constant. We could replace u by its value, which is sin x, and we'll end up getting the result of integration of the sin x cosine x dx will be sin square x over 2 plus constant. Now we will go ahead and do the substitution, but this time not for sin x, for cosine x. So let u equal to cosine x, and then derivative of both sides will give us du equal to negative sin x dx. Dividing both sides by negative sin x, we will get du over negative sin x equal to dx. We just divide the left term by negative sin x and the right term by negative sin x. We'll be solving for dx. So dx is equal to du over negative sin x. Now we're ready to do the substitution. Instead of cosine x, we use u. We keep sin x the same. And instead of dx, we use its value, which is du over negative sin x. Once again, we realize that there is a common term between the numerator and denominator, and that is sin x. So let's get rid of them. Now we simplified the question to integration of u du, but we'll also preserve the negative sign on the denominator, so we will have it to the left of the integral sign. So negative integral of u du will give us negative of u squared divided by 2 plus constant. We can replace u by cosine x, and that will give us the answer to be equal to negative cosine square x over 2 plus constant. This is our second solution. Now we will go ahead and make the hypothesis for the third solution, and we will prove it later on. So we're also claiming that integration of sin x cosine x dx is equal to negative half, and then between parentheses, open parentheses, sin square x over 2 minus cosine square x over 2, close the parentheses. To prove this part, we're going to go ahead and use a couple of steps here. First, we'll list the integration of sin x cosine x dx. And then second, we can tell that to get the integration, we'll just take a look at the first function, which is sine x, and we just square sine x, and then subtract from it the square of the second function, which is cosine x. So we take the first sine x, get its square, we take the second sine x, get its square, and subtract it from the first, and then the result, we have to get 1/4 of it. This is what we want to prove, and if we prove this, we would have proved the hypothesis that we talked about in a minute. So let's get going on proving this part. But before that, we need to review some of the equalities that will help us. For example, sine x plus y equal to sine x cosine y plus sine y cosine x. If we use x equals to y, then the left hand side will be sine 2x, and the right hand side will be sine x cosine x plus sine x cosine x, which will lead us to 2 sine x cosine x. Now we concentrate on sine 2x equal to 2 sine x cosine x. If we divide both sides by 2 and switch the sides, we will get sine x cosine x equal to 1/2 of sine 2x. Now if we put the integration sign on the left and the integration sign on the right, this is our original function. So it is equal to the integration of 1/2 of sine 2x. Integration of 1/2 of sine 2x. So let's follow this integration. Since 1/2 could be taken outside the integral, so it will be 1/2 and then integration of sine 2x. That's equal to the 1/2, and then the integration of sine 2x will give us another 1/2, and since the sine integrates as negative cosine, so we will have minus 1/2 cosine 2x as the integration of sine 2x. If we do the math, then this will lead us to the integration equal to multiplication of these two halves will give us negative 1/4 and cosine 2x. This we can consider it as result number 3. Let's go ahead and repeat the same thing we did with sine with cosine. So cosine x plus y equal to cosine x cosine y minus sine x sine y. We'll do the same by equating x to y. Then we will have cosine 2x equal to, and these two will be cosine x cosine x. So cosine x square minus sine x minus sine x square. Now that we have this, then we can also do the integration of sine x cosine x dx, and then remember we said that we will prove that it will be equal to sine square over 4 minus cosine x square over 4. We'll go back to the diagram and compare. We can see that this is the left term, which is right here, and this is the right term, which is right here. This is where we stop. So all of this is to tell that if we have this derivative, this is the answer. And now we can use the fundamental theorem of calculus. We want to show that this is indeed the integral of this. So we will integrate both sides, and if we differentiate both sides. If we differentiate both sides, then this value should give us sine x cosine x. Let's go ahead and proceed with that. But before we can do the derivative to apply the fundamental theorem of calculus, we will go ahead and make sure that we are simplifying this too. So this we could simplify it by eliminating the sine square. And we know sine square x is equal to half 1 minus cosine 2x. So that half will give us 1 over 8. And then 1 minus cosine 2x. And likewise, cosine square x is equal to half, between parentheses, 1 plus cosine 2x. And if we multiply the half by the 1/4, because the 1/4 is common between these two, so it will be 1 over 8, but it will be 1 plus cosine 2x over 8. Now we have these two terms, we can collect them together, and if we do so, we're going to get twice, because the 1 cancels with 1, and then we will have minus cosine 2x, and the minus will also give us minus cosine 2x. We will have minus 2 cosine 2x divided by 8, but that will give us minus cosine 2x divided by 4. Now that we have this value, now we're going to go ahead and do the derivative, because this value is equal to this value. And if the derivative of this is going to give us this function, sine x cosine x, as if we just applied the derivative of the integral and then the derivative canceled the integral. That is applying the fundamental theorem of calculus. So we're getting the derivative of this, but in the simpler formula as this. So this is a simpler formula. So we will get derivative of this simpler formula, but then we know that the derivative of negative cosine, normally the derivative of cosine is negative sine. So negative with negative is going to give us positive. And the function cosine 2x will be sine 2x, and then the derivative of the parameter will give us 2. And the 2 is going to balance the 4, so we can go ahead and show that we can cancel the 2 over here, and we will have 2 in the denominator. So the result will be sine 2x over 2. Now we can expand sine 2x. If we expand sine 2x, it will give us 2 sine x cosine x. And the 2 will cancel out with the 2 in the denominator. So we'll be left with sine x cosine x. One more time. What we did is we placed the question that we were looking for solution, which is integration of sine x cosine x. And we got the result of the integration. So this is the result of the integration. We simplified the result of the integration until we get to this point. And then we did the differentiation of the integral. The differentiation of the integral should lead us to this function that's integrated. And differentiation of the integral, sure enough, led us to the function. By just going down over here and deleting the 2, we will get the function sine x cosine x. That's it for now, and thank you for watching our video. If you have any comments, please feel free to send us. Thank you, and you have a great day.